I think that this cover here is quite fitting. The three bears that you see here, the one to the left side looks a little bit young, thinks everything is possible in a way, like, yeah, we want to do this cool stuff. Then in the middle, you have more or less this older bear, which says, okay, I'm going to implement it. And then on the right side, you have the reality. It's not easy. You have to fix a lot of things, and you have also a lot of challenges. Yeah, so as Michael said, I am coming from Angular Architects. So we are doing micro frontends already for a very, very long time. And that's also why we see, especially for our customers, they are using micro frontends. So we see the different variations which do exist. And I also want to bring in here some of these things in this talk here as well. Good. Your introduction, we had it already. Maybe first of all, what are micro frontends? So the basic idea of micro frontends is that you say, well, you have an Angular application, or maybe also coming from some other front-end frameworks. You want to split it up into multiple sub-applications, and during the runtime, all of them should be merged together. My definition is a little bit different. What I always try to say is that micro frontends, at least the way how it's used most of the time, is this kind of art to really transform an organizational problem that you have into a technical one. So we as developers, we are not able to fix things in the organization and the structure of the teams and all of that. So, but someone needs to fix those issues, and that's why we say, okay, maybe from an organizational perspective, we can't fix it, so we try to fix it in the technical scope, more or less. And this is what it really is all about. And this is also the main necessity for micro frontends. You want to go with it if you have too many people working on the same project. This is the reason. Yeah. So if you say let's hundreds developers working on the same project, you're losing the possibility to coordinate them, and this is the big problem. There are also other reasons. Build time, separate deployment is also something we hear very often. Build time, we know you usually when you have a code base of a decent amount, then we tend to use very often NX. It has the caching built in, but there are also some things which can be faster than caches if we don't have to build the things at all. And this is also what we can do with micro frontends. You only build just a micro frontend and leave the rest as they are. Separate deployment is also a good thing, if someone needs it, but in the end, it's really the coordination problem inside of an organization. Then, what I also want to kind of highlight is that very often we are dealing with the idea for micro frontends coming from the management, that they were reading some kind of papers or whatever, and they are saying, well, this is the same that as microservices that we have in the backend. We saw that it works there. It will also work in the front end because the front end is always the easier part. And then we have to clarify. There are some differences between microservices and micro frontends. First of all, with microservices, we use them very often to scale. So I say I need to boot up 50,000 nodes because I need to serve my 1 million users or whatever. With micro frontends, that's not a necessity. I mean, this is a front-end framework. We have every user has its own node because the micro frontend is deployed into the browser. So there is no technical scalability necessary. That's one thing. The other thing is we don't really have a full isolation. So if you say again, looking at microservices, you can say, well, it's a physical machine or a virtual machine or a pod or whatever you use. There is really an isolation, so they can really kind of interact or kind of interfere with each other, except those boundaries or those APIs that you have defined. With micro frontends, it's different. We load the thing into the browser. There are some global things in the browser, like the window object and some other things, and all the micro frontends have access to that. So it's not like you have a full isolation. And then the last thing is that the frameworks, they don't have micro frontend support out of the box. This is then also, I don't want to say a problematic thing, but if you go with the micro frontend path, you have to be aware of it. We have some tools available that help you building micro frontends, but in the end, it's everywhere you go, you always have some customizations that people have to build on their own, and as soon as you start to build customizations, you are in no man's land. No one will help you. It's your own code. and then you need to be able to control what you're doing. And what we see is that very often there is some kind of special task force team. So there is a group which know exactly how Angular works. They also need to read the source code and all that stuff. So they are really experts, and they are there to keep this all running. Yep, so remember this. Micro frontends means you need to have a specialized group which knows about all that stuff. Highly advanced people. Yeah, and this is kind of a simple image if I forget to mention it. That's the Zauberlehrling, or the, I don't know how it is called in English, the sorcerer's apprentice. If you know this poem, you know what happens. So the master goes away and the apprentice stays and wants to do the same magic, a little bit uneducated, and then all of a sudden everything gets loose. Good. Let's say we go now micro frontends. The main building blocks that we always see is you have one application and it is separated into two pieces. We have a shell. So the shell is kind of the main unit in all of it, and the shell is then responsible to load micro frontends. It also knows when to show them. It will probably also provide some central services like communication or something like this, a message broker, because some communication might be necessary, and very likely that this shell is then written by this special task force team. Now, there are some frameworks for that as well, but we see very often that companies need to write their own shell. So, and what are now the common implementations that we see most often? The first one, and Martina will not be happy about it, iframes. They are still there. They are still there. Companies are using still iframes. We know it has some security concerns, also in terms of layout and so on and so forth, but we really see iframes. There are even frameworks which are built on top of iframes, and I can already tell you it looks like that there is something in the making, that something which might come out in the future, which might be a potential candidate, will also be based on iframes. But that comes at the end. Web components is also something we can use, but most of the time I would say modern micro frontends is done with module or native federation. I've put both together. I mean, there are differences obviously, but from the approach that they have, it's kind of the same. Good. Then I would say let's start with web components. What are they? Web components in the end, we can create them by Angular, so there is a support from the framework. We can say we have an application, Angular application, we want to have a web component out of it, and then we're getting one JavaScript file which contains the complete application. We take this JavaScript file, we go into the shell loads it, the shell assigns to this custom element, to the web component, a certain tag, and whenever the browser sees that tag, it kind of renders this app component. This is the way how it works. Web components is an umbrella term. If you look it up at MDN, you will see it's a combination of Shadow DOM, of custom elements, and also of HTML templates. But in the end, when we talk about web components, we mean the whole set. And as I said, it's kind of this squeezing the complete Angular application into one tag. So this is how you can kind of see it. And this is then also how it looks like. So from a high-level view, we have our shell that runs Angular, and then we have multiple Angular applications running in the same browser because we are using web components. And this comes already now with a lot of disadvantages, obviously. I also have to say that web components, I see them nowadays as something from the past. For micro frontends, they have found their niche, so there is some use for them, but not to kind of re-implement these full-grown micro frontends. The main problem is definitely the bundle size. So with every web component, we add another Angular application, so that really grows in size. I have seen once a website from a bank where they said they need to go with web components, and there they said the initial bundle size, the total of the bundle sizes that they had were 30 megabytes. They could afford it. They were running also on the internet, but they said, it's the bank. If you want to do something, you need to come to us, so we can afford it to have this long loading time. But of course, it's not optimal. That's not the question. Multiple Angular instance, and with that, there are also coming now some certain challenges. First of all, you might have issues with the router. We know this. If you say provide router or router module for root, you have to be careful. because then again, the Angular routing system wants to connect to the history API, and then you don't know what happens if multiple Angular applications want to access the same thing. That's an implementation detail of the framework. We don't know, it could change, but it's just a potential collision that we could have done. So you have to think about alternatives, how you can do it. Zone.js used to be also a huge problem in the past. I think in the meantime, there is a solution for that. Just go zoneless, then you don't have the problem anymore. Exactly. So I would kind of say yes, that it used to be. And then the niche case. So I said before, web components are still used, but for UI components. So whenever we have something, a UI library, where we say this is meant for corporate identity, we want to use it also maybe in React or in Vue, whatever, then this is where we see web components quite often. The question is then also, do you really want to use Angular for it? In the end, it's just HTML and a little bit of JavaScript. You know, if you only use Angular, then you have to be careful about the bundle size, but usually there are then kind of specialized other frameworks which you can then also use. The advantage is you get this high isolation. This is true. And this can also be a disadvantage, because if you say there needs to be a certain amount of communication between these micro frontends, well, then it's going to be a little bit harder. Good. So that's web components. Let's move on to the main part. Yeah, or maybe, yeah, good. I have to say this as well. Before module federation appeared, we tried to kind of work on solutions for web components, sharing dependencies especially. For example, if we use Angular 18 for 5 different web components, then it would make sense to load it only once. And there have been some tools like Webpack externals, where you could say during the build time, you don't want that the Angular framework is now part of this web component. You want to load it separately somewhere else. You know, that also exists, but I think it's not really the current direction that we're going to. Module federation. What is module federation? So let's say we have one application, and in this application we have the Angular framework, we have also third-party libraries, and then we have a certain feature which a team wants to work on. So, and this feature, and this is how it starts, it needs to be lazy loaded. Then let's say we have another application where the same thing happens. Careful again, this is not like meant you have the feature is just one component and 5 people are working on it. It's really like it's a big feature. So it's usually much, much larger than just 2 or 3 files. Then it does make sense, because otherwise you can put everything together. Good. So we have then these 2 features, and they are now becoming candidates for micro frontends. So let's put them to the side. What I maybe want to highlight, when we are in the scope of module federation, the terms also change a little bit, the terminology. We used to call the micro frontend then the remote, and the shell, then we usually use the term host for it. Good. The host is here on the right side. It's empty, so it provides the shell. It provides also the Angular framework, some third-party libraries. So far, so good. And then we start with the compilation. Because the feature is lazy loaded, we get one JavaScript file which only contains the application code for this feature. If it's using NgX or something else, then the third-party libraries will end up in another JavaScript bundle, which you see here in white color. The Angular framework, of course, is also part of it, but not of the lazy loaded feature bundle. The host is doing the same, it also builds. And then we have the possibility to say, well, all 3 applications that we see here can be hosted on different domains. So I can say host 1, host 2. These are the micro frontends. It could be simple file web server, so just serving files and nothing else. And the shell also. Now, when the shell wants to load now the green feature, then it would more or less just say, okay, I'm now requesting only that JavaScript file with the application code, and I ignore the rest. So I'm only loading the JavaScript file from host 1. And it can do the same also to host 2. The reason why it can do that, why we can only load the JavaScript file, the application code, and nothing else, is that the shell contains already the Angular framework and also maybe a lot of third-party libraries. So it's already there. We don't need to bring in the Angular framework from the other micro frontends as we have done it with the web components. That is the trick here. The question now is, and this is now where it becomes interesting, how do we deal with those sharing of libraries? Yeah, let's say you have NGRX, you have Angular Material, you have RxState or whatever. This is also something which is quite common, that in large organizations different state management libraries are used. But how do we continue them? You can and you should share libraries. So there are some settings. That's also the default behavior. What module federation is doing, it says if I have already loaded one particular library, then I keep it. And then if another micro frontend needs to use the same library, then it gets the one that I have already loaded. That's the default setting. So it should be shared. There are some edge cases where you want to load a library multiple times. That could be that maybe there are different versions, but there you have to already be very careful, which comes afterwards. But you can also load your, for example, what a use case was now that I've seen is an open API library, 3 different micro frontends. They the one was using the open API version from half a year ago. The other one was using a modern one with a new API version. And then they said, well, we need to load multiple versions of that open API library. I know it's the same kind of name, but this needs to be possible. But yeah, these are edge cases. We don't see it that often. This is the problem of module federation, because it sounds too good already. There is, as we all know, Angular is compiled. So the commands that we write, they will likely look a little bit different. There will be other commands which the compiler will use in our final bundle in the JavaScript. Now we know that there is such a thing like semantic versioning. Yeah, so this means if I have a form group and I say form builder group or something else, then I can rely that if I use Angular 18, that it works in Angular 18.1 and in Angular 18.2. But as soon as it's 19, I need to be careful. There could be a breaking change, although most of the cases there isn't one. So in a way, we could say, well, then I can just mix all my Angular versions. Why not? This should be possible. Yeah, but the problem is the commands that you see in your source code are not the ones that you are then running in the browser or when it's compiled. And the Angular says this API that is used in the bundle in the compiled code is not a public API, so we are not in a way there is no necessity for us to follow the semantic versioning. Which could mean that even within a patch release, in a different patch level, there could be a breaking change somewhere, and then you have a real problem. So if you say you're using Angular 18.01, 18.0 you mix both together, it could happen, it might not happen, but it could happen that there are some incompatibilities. And then, yeah, you will not get a real error message. We don't really know what's happening. It's a little bit risky, so to say. Alex, do you want to say something about this? Yeah.
That was a great explanation.
Okay, yeah. So I heard the explanation from Inko 3 years ago, and I also asked him, did you ever actually encounter such an issue with different patch versions? And he said, yesterday. I said, okay, good. So yeah, again, so it's a little bit risky if you mix multiple Angular versions together, and it doesn't only apply to Angular framework itself, but every Angular library as well. So everything which is compiled with the Angular, which obviously is quite a lot. There are, though, runtime protections built in. So we know of this issue. Module federation has something to help you. And I had to remove the slide. So what you could do in module federation, it comes with 2 different parameters. You have strict version enabled and you have singleton. You can tell module federation, I only want to have one instance of a certain library. And then in addition, you also say it needs to be strict versioning. If you say you only want to have a singleton and you're running within multiple libraries in the same major version, then module federation would say, okay, they all should follow semantic versioning, so I'm just taking the highest version. Yeah, but not so with Angular. With Angular, we need to say it needs to be 18.1, 18.01, or 18.02, but I'm not going to allow anything else. And what you will get then during the runtime is an error. So it will then fail, and then you know at least that it's not going to work. This is this runtime protection that we have. There is a tweet from Brendan Roberts, which I saw yesterday. I thought, yeah, it's a good opportunity to include it here as well. So careful, you really have to see it like internal API that you are using there. Good, good. So, yeah, so this is what we see here. We are loading now third-party libraries. Let's say it's NGRX or something else. And then there is this module federation logic included that I've just explained. So it will find, depending on the settings that you have done, it knows what it has to do, and hopefully there are no collisions. So module federations. In the end, we don't have these disadvantages that we have from, for example, from web components, because we have just one Angular application running, and that's a good thing. Also for Angular itself, there are no bad surprises. Because from the perspective of Angular, there is just one Angular framework, and it loads just lazy loaded modules like it would also normally do. The only difference is that this lazy loaded module is now coming from a different location. Yeah. But if everything kind of fits together, it's one Angular application at the end. This is the big advantage. Which means you don't have issues with multiple zone jazz. You don't have issues with the router. You don't have issues with dependency injection at all. If you use the HTTP client, the interceptors will work for all your microfrontends. And then also you can also share services. If you have a user service, the central platform services that are provided by the shell, then you can reuse them also in your microfrontends. That's a good thing. The bundle size is also nice. Yeah, obviously, because we don't have multiple Angular versions. But careful, it's suboptimal because we cannot do tree shaking for shared libraries, obviously. If I'm the shell, or if I need to build a library, then usually tree shaking, we know what kind of things from the library we require, and everything which is not used gets kind of thrown away. But with the microfrontend, I don't know who's going to use that library, so I need to play it safe, and I need to include everything that this library from its API is exposing. So this is, yeah, bundle size is good, but it's not tree shakeable. There is this compromise where we say, yes, it is as it is with this versioning of Angular. We need to be careful there. And then the question always comes up, yeah, but if we, again, need to be even on the same patch level, how can we reach this full autonomy? And then, yeah, monorepository is always a good approach. You're coupled. We have to be. You're bound to the versions, to the libraries. There is no autonomy, but it leads to everything else. You can have separate deployment. You can use a different state management library. So this is all possible. Right, and it's also bound to the bundler. And this means I use, for example, in the use case of NX, we have Webpack and the NX, which means during the runtime, the loader needs to know, okay, this is now a JavaScript file which was built with Webpack. This is one which was built with RSPack. And this is now where we come to native federation. Yeah, because this is now the one of the main differences between these two approaches. I also want to say maybe a quick, so module federation, when it came out, it's the pioneering work for Angular was done by Manfred, also Manfred Steyer, obviously, and he had this contact to Tobias Koppas, who used to be at the time the Webpack lead, and he brought in the prototype for Angular, and then from there on, it kind of found its way into other environments as well. And today, for example, NX is also known to have a very good support for module federation. Native federation is then something where I would say this comes more from us, from Angular architects. It's like module federation, but without this kind of coupling to the bundler during the runtime. Yeah, so this during the runtime, that is important. If we take here a look at module federation, and in this case, I would say that's the NX use case, then at the moment we can say Webpack or RSPack. This is used then to build the JavaScript files, and these JavaScript files, they have a little bit of metadata, which is then understood by Webpack because it needs to load it during the runtime. What native federation is doing, it says we also obviously need to use a builder. So in our case, we are using ESBuild at the moment, but what changes now is that the outcome of the JavaScript file is not like an ESBuild format, it's ESM. Which means we could theoretically, I mean, there is at the moment just one adapter, but we could have multiple bundlers, different bundles for the microfrontends, because during the runtime, it only accepts ESM. So everything that you need to do is that you need to make sure that the bundler that you are using is producing ESM. That's the main thing. So this is what I meant with we are decoupled from the bundler during the runtime. But yeah, again, the net adapter is necessary. So if we want to support Webpack, RSPack, Vite, someone needs to write that adapter which is doing the ESM compilation. It also opens it up the new use cases. We could, for example, make use of CDNs. So if you say there is a CDN which provides the Angular framework in ESM, then we can just very easily point to that, and chances are very high the more native federation is used, that it also is more in your cache already, and you don't need to load it then from your own application. It's also web standard, so we're using import maps in the end, which means we are telling the browser, if someone is importing from ABC, you fetch the file from this location, from this URL. And we can also use module federation as well. That's one of the latest features, so we can use both. And this is the downside, you require ESM. So if you have a CommonJS library in the end, in your node modules, for example, you cannot share it. This is something which you could do with Webpack or with RSpec, but with native federation, it really is like it's then part of the micro frontend. Good for us because in Angular, all the libraries are already running on ESM. So it's really like libraries, Lodash, DateFNS, something like this. If they are kind of coming without ESM, yeah, then you need to exclude it from the shared part. And that was, these were the three main implementations we see. I also have a few other ones. The hyperlink integration, which always comes up in the topic of micro frontends, that actually means you don't do micro frontends, but you split up your application into multiple domains. So for me, that's not a micro frontend, but that's the last exit before I really go straight into micro frontends. That's an alternative. SingleSpar is a framework which kind of is framework agnostic. It allows you also to use other front-end frameworks as well. You can mix React. I don't know if they still support AngularJS. Custom solutions. We have the story of Google Cloud, where they have 2,000 Angular developers working on one project. What they are using is they have two iframes. One iframe is always shown. The other iframe is the container for the micro frontend, and they are mirroring what the micro frontend iframe is doing into the main iframe. So the user never sees the micro frontend iframe, but they're kind of mirroring all the things into the main iframe. Yeah. Also works. You have then full isolation, and maybe at that scope or at that dimensions, you can allow to do it. There are also hybrid things that are possible. You can mix module native federation even with web components. Typical use case, big organization, internal development happens. The internal development, they are working within a single monorepository. There you have the versions under control. There you can then use native federation. You have some external companies which also provide you micro frontends. You integrate them with web components. That is also a possibility which is quite common. And web fragments. This is something which was announced last week at NG Belgium. I've heard about it the first time. I wanted to bring up a showcase. It's not at the moment where I would say we can already, it's already production ready. But this is a technology coming from Cloudflare together with others, from Igor Minar, who used to be at Angular for a very long time. And they are also depending on iframes. So this is very interesting. Yeah. So in the future, if you hear web fragments, you've heard it here for the first time. Good. Except you have been to NG Belgium. Good. And that was it from my side. Thank you very much.